Hello everyone, it's Mr. Zong back with the lesson. Now today we're going to have a big lesson. It's a big lesson because it's a lot of content to cover, so make sure you pay attention. So in today's lesson, we're going to go through points of intersection with non-linear relationships. So as you still remember in the past, you probably learned about points of intersection between two straight lines, where, if you still remember, there are two methods to do this. You can either do the graphical method, which I think is the more annoying method because you have to actually draw the graphs. So it says requiring sketching the two graphs and it needs to be accurate on a number plane. And then you read the point of intersection of the diagram. So I wouldn't recommend this unless you have to. Now the algebraic method, that's the one I strongly recommend you guys do. And this uses simultaneous equations to solve for the point of intersection. So for those of you that don't remember simultaneous equations, I suggest you do some more revision because it's a topic that students tend to forget a lot. So let's just get straight into it. Now the question asks you to use the graphical method to find the point of intersection between the lines y equals 2x plus 3 and x plus 2y equals 6. So this should be a revision question, as you've done this question before, so I'm just going to do it again. So to draw the two straight lines, first, what I will do is I'll find the x and y intercepts. So when you have y is equal to 2x plus 3, to find the y-intercept, you let the x equals 0. So then y equals to 0 plus 3, which equals to 3. So that's the y-intercept. And to find the x-intercept, you let y equal to 0. So then, so 0 is equal to 2x plus 3. So then you have minus 2x is equal to 3. X equals to 3 over minus 2, which is the same as minus 3 over 2, right? I can move the minus to the top. Okay, so let's sketch the first graph. So the x-intercept is minus 1.5, so that's somewhere here. Minus 3 over 2. And the y-intercept is 3, so 1, 2, 3. Okay, now let's draw the graph. So I'm going to use... Okay, that's not the best, but try again. Straight line. Okay, the graph will look something like this. Now, the next step is to find the x and y intercepts of x plus 2y is equal to 6. Okay, so x plus 2y is equal to 6. Find the y-intercept first. Let x equal 0. So 0 plus 2y is equal to 6. So then 2y equals to 6. Y is equal to 3. So y is equal to 3. Right. Okay. Now let's find the x-intercept. So let y equal to 0. So x plus 2 times 0 is equal to 6. X is equal to 6. So the x-intercept is 6. So 1, 2, 3, 4, 5, 6. And let's sketch a line. Actually, I'll draw a line that looks like this. There we go. And let's just label the arrows for this line as well. Just so that, because we know that the line is continuous. Alright, so as you can see from the two lines, there's one point of intersection. Hence, the solution is what? So what is this point? This is the point 0, 3. Therefore, the solution is x is equal to 0, y is equal to 3. Right? So this will be your point of the intersection. Alternatively, what you can say is, so you can just write the point 0, 3. Because the question actually asks you to find the point of the intersection. So I actually strongly recommend you write this. Okay, but if you write this, it's also acceptable. All right, now this question will ask you to do the question the algebraic way, and that's my favorite method. Okay, so this is called simultaneous equations. So you have equation 1. So what I will do is write the two equations. Y equals to 2x plus 3, and x plus 2y is equal to 6. So these are your two equations, and if you still remember, there's three ways of doing simultaneous equations. There's the graphical way, there's substitution, and there's elimination. Now for this one, it looks like a substitution question because we already make y the subject. All we need to do is substitute this y value into here. So then what you can say is this: sub 1 into 2. So what you're left with is x plus 2. Now y is equal to 2x plus 3. So I sub that in, is equal to 6. So now what we have is we have a one variable equation. You see, there's only one variable. It's just x. Whereas in here, you have two variable equations, which you cannot solve. You can only solve one variable equations. So let's just keep going. So 4x plus 6 is equal to 6. Simplify the left-hand side. So you have, just continue from here, 5x plus 6 equals to 6. 5x is equal to 0. Take away 6 from both sides. X is equal to 0. Now, a common mistake a lot of students do is they stop over here. But you have to realize simultaneous equations means you have to solve for x and y. So if x equals 0, I can sub this x value back into equation 1 or equation 2. So I'm just going to pick equation 1 because it's easier. Y equals to 2 times 0 plus 3, which equals to 3. So that's your solution. Now it says to find the point of intersection, so you can either write it like this, or you can write, actually tell you what, because it says point of the intersection, I actually think it's better to write it in the point form. But if the question just asks you to solve these two equations simultaneously, then your answer should look something like this. Okay, now let's move on to some slightly harder questions. As you can see, this is a bit harder because this is a straight line and a non-straight line. So the graphical method to find the point of intersection between the line y equals 2x plus 3 and the parabola y equals x squared. Okay, beautiful. They already sketched the graph for us. So what we need to do is just find the 2 points. Okay, so it says find the point of intersection. So this is our first point. This is our second point. Right. Okay. So now what are the coordinates of the first point? So as you can see, this is somewhere that's between 2 and 4. So this is probably a 3. And what point is this? This is between 8 and 9. So it's 9, right? So then the point of the intersection should be 3, 9. And what would the coordinates of this point be? This will be minus 1 and this will be 1. So the 2 points of intersection is minus 1 and 1. Right? Okay, so hopefully that was quite clear. Now in the exam, it would be very annoying if they asked you to do this question using the graphical method, because then you have to draw it perfectly to find the two solutions. So most likely they'll ask you to solve it algebraically. Use the algebraic method to find the point of intersection between this and that. And this is something I've actually covered with you guys in term 2, if you still remember. But I think most of you may have forgotten this because this was a challenging topic. But nevertheless, we can revisit it. Now with a question like this, right? So the methods to simultaneous equations still apply here. Remember, there's the substitution method or there's the elimination method. Now for this one, we can't really use we can use elimination method as well, but I think it's easier to just substitute because this is y is already made the subject. So I can just substitute the value of y here into here, right? So I can just say sub 1 into 2. So I sub the 2x plus 3 into here. So I get 2x plus 3 is equal to x squared, right? So then now what you need to do is you need to solve this equation. And as you still remember, this is just going to be a quadratic equation, right? So I just need to make sure I turn it into a quadratic equation. So I take away 2x and 3 from both sides. So x squared minus 2x minus 3 gives you 0. And to solve this, if you still remember, you need to factorize. So x minus 3. So two numbers are multiplied to give minus 3 and add to give minus 2. So then x equals to 3 and minus 1. And then what does y equal to? So when x is equal to 3, y is equal to x squared, which is 9. So I can substitute these 2 points back into equation 1 or 2. I'm going to sub it into 2 because it's easier. And what's minus 1 squared? It's 1. So then once you get to this step, please just don't stop. Keep going, because if you leave your answer like this, you won't actually get the full marks. Because the question says find the point of intersection. So therefore, point of intersection, so you can write POI are, you have 3, 9, and then you have -1 and 1. Okay, so make sure you write your answer in this form. Now, say if the question doesn't ask you to write the point of intersection, just says use algebraic method to solve simultaneously this and that. What I strongly recommend you do is write your answer like this. So therefore, solutions are x equals to 3, y equals to 9, and x equals to -1, y equals to 1. So I want you to write your answer like this rather than like this, because this is how you're meant to give the solution. There's actually 2 sets of solutions rather than 4 individual solutions, if that makes sense. Okay, so this can be part of your working out, but in your final answer, if the question says find the points of intersection, I want you to write it like this. But if the question just says solve it simultaneously, then I want you to write your answer like this. Okay, so hopefully that's quite clear. Do not write like that, but that can be part of your working out. All right. Now the next question says use the graph to approximate the point of intersection between the straight line 3 minus x and y equals 2 over x plus 2. Okay, so because it's drawn for you, it's pretty good. So as you can see, it's to approximate it, so it's going to be this point and that point, right? So to approximate it, let's see. So this is 3. So this is going to be between 2 and 3. So that would be 2.5. And what's the y value? The y value, it looks like it's so this will be 1. This will be 0.5, right? So the y value looks like 0.5. All right. And then what's the other solution? The other solution is the coordinates of this. So this will be, so I know this is -1, so this should be -1.5. And the y value should be here. So as you can see, this is the value 5, so this should be 4.5. Okay, so I mean, hopefully doing it like this is quite easy when it's drawn for you, but I think in the exam it's not likely they can ask you this, because it is quite annoying to draw, especially if you have to draw to scale. Now, make sure you understand this one, because this is definitely something they can ask, and many students will struggle with this because it's not something they're familiar with. But don't worry, I'm here to help you out. So you have equation 1, and you have equation 2, and you have to find the point of intersection, right? So like I said, generally with simultaneous equations involving a straight line and a curved line, you're most likely going to be using the substitution method and not the elimination method. And the way that it's written makes it just very easy to substitute. You can just substitute 1 into 2, right? What that means is you're substituting this into there, right? Okay, so I hope that's quite clear. All right, so then to do that, so then you have 3 minus x is equal to 2 over x plus 2. Now, how would I solve this? So as you can see, we have a fraction here, and we do not like fractions. We want to get rid of the fractions. So to get rid of the fraction, what we can do is we can multiply both sides by the x plus 2, right? So multiply x plus 2, multiply x plus 2. And remember, when you multiply the left-hand side by x plus 2, you're multiplying the whole thing. So what you should be left with is 3 minus x plus 2 is equal to this number times x plus 2. And because we're multiplying by the denominator will just vanish. Okay, so you get this. And then to solve this, you need to expand using the FOIL method. So 3x plus 6 minus x squared minus 2x is equal to 2. Gather like terms, so I have 3x minus 2x, which is x, plus 6 minus x squared is equal to 2. Right. Now, because I don't like it when the number in front of x squared is negative, so I'm just going to move this to the right hand side. So then I'm going to have x plus 6 is equal to x squared plus 2. In fact, I'm going to move everything to the right hand side, so then I get a quadratic. So then I should have 0 is equal to x squared minus x, right? And then I also take away the 6, so then what I should end up here is minus 4 is equal to 0. Oh, oops. Sorry, there's no 0 there because I already read the 0. So that's the equation that we have, right? Now we need to solve this. So how can we solve this? So to solve this, we can use the factorizing method. So see if we can find two numbers that multiply to give minus 4 and add to give minus 1. So that's not impossible, right? So because it's not possible, we need to use the quadratic formula. Okay, so let's just use the quadratic formula. So then x equals to, remember, write the quadratic formula first, plus or minus the square root of b squared minus 4ac over 2a. Alright, so in this case, what is b? So b is, I'm just going to continue from here, b equals to minus 1. Actually, a equals to 1. And c is equal to the minus 4. Right. So then now we just have to substitute it in. So x is equal to, so minus 1, which is 1, plus or minus the square root of b squared. So 1. B squared is 1, minus 4ac. 4 times 1 times c over 2a, so 2. So then x equals to 1 plus or minus the square root of, now this is 1 minus 16, so 1 minus root 17 over 2. Now, once you get the x value, you need to get the y value, right? So let me just double check what this value is. So 1 plus square root of 17 over 2. So that's about 2.56. So this is kind of close to the value that we have here. So we're on the right track. So what you can do is, rather than substituting this value back in, actually tell you what, we can give this an approximation value just so that we can substitute it back into y. So you can say that's equal to 2.56, and then to get the other value, so you got to change this to a minus. So minus 1.56, okay. So minus 1.56, and you can write 2dp. So then you can say y is equal to 3 take away 2.56. So what's that? 0.44, or 3 take away minus 1.56. So what's that? That's 4.56, right? 2dp. So then what you can say is, therefore, POI is 2.56, 0.44, and minus 1.56, 4.56, right? So that's how you get to the solution using the algebraic method. And I agree, this algebraic method is pretty complicated, but make sure you understand every single step. So in my opinion, the most complicated step is actually going from this step to this step, because you have to multiply everything by the x plus 2. What some students will do is they'll just multiply the 3 by the x plus 2, and they'll forget about the minus x. So make sure you study this example. Okay. Alright, so the next question says, what is the point of intersection between the straight line and the circle? And as you can see from the graph, it's very easy to do. You just have to read off the 2 points, right? So let's read off this point. This should be 0, 5. Okay, so this is 0, 5. And what's the other point? This is 4, and this is minus 3, right? So then 4 minus 3. Alright, so that's done. Now they want you to do it the algebraic method, and that's the hard way now, okay? It's not the easy way, so let's just do it. There's a lot of the algebra involved, so make sure you pay attention. So you have 2x plus, so like the other questions, just write out the two equations first. And you have x squared plus y squared equals to 25. Now, it's most likely going to be a substitution method. So to substitute this into this, you can't do it straight away. So what I'll do is I'll make y the subject first. So this will become y is equal to 5 minus 2x. And I can just say this is the equation 3. Okay. So once I've made y the subject, I can substitute into here. And it's going to be a lot of algebra from here. So sub 3 into 2. I can already see this. So I can already feel it coming. A lot of algebra. So then what you have is x squared plus 5 minus 2x squared is equal to 25. So then to do this, you need to expand this. So you have x squared plus, now if you still remember the quick way to do this, it's the a squared minus 2ab. So that's 20x plus b squared, so plus 4x squared. If you don't remember, try to revise on this topic. Equals to 25. Alright, now I'm going to just continue from here. So then just collect the like terms. So 5x squared. And I'm going to write it with the x squared in the front, and then the x, and then the number. So 5x squared minus 20x plus 25 is equal to 25. So as you can see, there's a 25 on both sides, so you can just cancel them out. So I'm left with 5x squared minus 20x is equal to 0. Now, in here, what you can do is you can also divide both sides by 5. Okay, so you have x squared. X squared minus 4x is equal to 0. Make sure you divide by 5 and do not divide by 5x, because we do not want to divide by an unknown variable. Alright, so once you get to this step, then it becomes quite straightforward. Just factorize it. X times x minus 4 is equal to 0. So then what does x become? X equals to 0 or 4, right? Now when x equals 0 or 4, what does y the equal to? It's a little bit buggy. So substitute x into either equation 1, 2, or 3. Now I'm just going to sub into 3 because I think it's the easiest. You have y equals 5 take away 2 times 0. If you substitute the x equals 0, so you get 5. And if x is equal to 4, you get y equals to 5 take away 2 times 4, which is 5 take away 8, which is a minus 3. So then the point of the intersection are what? Point of intersection is x equals 0, y equals 5, and x equals 4, y equals minus 3. Okay, so that's your solution. So just to recap today's lesson. So today is actually pretty much a lesson on algebra. It's not so much on curve sketching, because in today's lesson, we only actually drew the graph once. Whereas for most of the questions, what we did was we used the algebraic method. And to do questions using the algebraic method, make sure that you use the substitution method. Okay, so in here, you can see that I substituted this straight line into here, so we get a quadratic. And for most questions, after the substitution, you're going to get a quadratic of some sort. So make sure you learn how to solve your quadratic equations. For most questions, you can just solve by factorizing. For a question like this one, you need to use the quadratic formula. So as you can see, because I cannot factorize this, I had to use the quadratic formula. And once I used the quadratic formula, the answers that I got were quite similar to the answers that I had here, right? Alright, so that's all for today. If you have any questions, please post onto Google Classroom or send me a message. For homework, I only want you to do exercise 7.13, okay? I don't want to give you too much homework and create too much stress. Okay, so that's all for today. Thank you for listening.